In any math course that you take, you're going to be asked to simplify your fractions, and that means reducing your fractions to lowest terms. So if I have the fraction 10 over 12, that can be simplified to 5 over 6. Both numbers are even. I cut them in half, and I get 5 over 6. 5 over 6 is a proper fraction. What if we had the fraction 9 over 6? Well, 3 goes into both of those, and I get 3 halves. 3 halves is in simplest form. You could write that as 1 1/2, but you don't have to. Most algebra books actually prefer your answer being left as an improper fraction. All right, let's practice a few. Now, it helps if you know your divisibility rules. I'll try and review them as we go along, but go back and look at a previous video and it might be beneficial. 48 over 64, both those numbers are even, so that means that I can divide both numerator and denominator by 2. Half of 48 is 24. Half of 64 is 32. Both still even. All right, keep going. Half is 12 and 16. Both still even. 6 over 8 and 3 over 4 would be your final answer. Now you can aim big if you want. Think of your greatest common factor and divide that. You don't have to take baby steps and keep dividing by 2. Do it any way you want. Just be careful that you don't make a careless mistake. So I'm thinking, well, I know 6 goes into both of those numbers. And you can do it this way too. You can say, well, I know 36 is 6 times 6, and 72 is 6 times 12. And if you do it this way, it's very visual. You don't have to hold it in your head. And 6 over 12, well, I know that's equal to 1/2. 80 over 120. Well, the rule for 10 is if the last digit ends in a 0, and it does. So I can just simply cross those off by dividing by 10, and I end up with 8 over 12. And I know 4 goes into each of those. So 4 times 2 is 8, and 4 times 3 is 12. 45 and 15, they end in a 5. That means 5 goes into both of those numbers. 45, again, you have 2 different ways you can do it. 9 times 5, and 15 is 3 times 5. Get rid of your 5s, and you're left with 9/3, which is equal to 3. Oh, 51 over 87, that's a tricky one. Let's see. It's not even. The numbers aren't even. They don't end in a 0, and they don't end in a 5. So let's go back and look at our rule for 3, which in my opinion is the most useful of all because it's not one that is so obvious. But the rule for 3 says if you add up the digits, like 5 plus 1, you get 6. 6 is a multiple of 3. That means 3 goes into 51. It doesn't tell you how many times. You just know that it goes in. So you'd have to do out the division. But it goes in 17 times. Same thing with 87. You might think that's prime. But if you add 8 and 7, you get 15. 3 goes into 15, so 3 will go into 87. And it will actually go in 29 times. So this fraction can be simplified to 7 over 29. If you're given a fraction and nothing goes into it, then it's already simplified. So you look at 14 and 35 and you think, okay, 14 is even and 35 ends in a 5. And then you're thinking that you can't do anything with it and that it must be already simplified. It's not true. Break it down. Put down whatever you know. You know 2 goes into 14. Well, it goes 7 times. And you know 5 goes into 35. How many times? Oh, 7. So that tells you that it can be simplified. All right. Copy down these numbers, put this on pause, and then when you're done, turn it back on and see how you did. All right. I took baby steps in this problem. I cut 32 and 48 were even, so I cut them in half. Still even, cut it in half. 8 over 12, still even, cut it in half. 4 over 6, and then 2 over 3. All right, 64, I decided to take bigger numbers. I knew 8 went into both of those. So 64 is 8 times 8, and 72 is 9 times 8. I can get rid of my 8s, and I'm left with 8, 9. 180, I got rid of my zeros. 18 over 36, cut it in half, 9 over 18. At that point I said, oh, that's equal to a half. 54 over 99, that's a little bit trickier. Well, what do you know? You know 54 is 9 times 6, oh, and 99 is 9 times 11. So you get rid of your 9s, and you're left with 6 over 11. 75 ends in a 5, and 90 ends in a 0, so I know 5 goes in. 75 is 5 times 15, and 90 is 5 times 18. And 15 is 3 times 5, and 18 is 3 times 6. So we end up with 5 over 6. 39 over 26, that's another tricky one. Let's see, I know that 3 goes into 39, so 3 times 13, and then I know 2 goes into 26, so by doing that, you're going to end up eventually seeing that 13 went into both numbers, not something that you'd think of, and 3 over 2 is an improper fraction, and you may leave it like that. Get rid of your zeros. 24 over 36. Think big. 2 times 12 and 3 times 12. End up with 2/3. And 91 and 105. All right, that's going to be a tricky one. So let's think. We know it's not your rule for 3. It's not your rule for 2 or 5 or 10. So you may not think of the 7. Actually, do your denominator first. You know 105 is 5 times 15. And then 15 is 3. What did I just say? 105 is 7 times 15, or put 5 in, that's what I'm trying to say. It's 5 times 20. I'm trying to remember the order in which I did this. I divided by 5 and got 3 times 7, because I got 21. So then you say, all right, here are the two 7s. Eventually we'll get through this. 13 over 15. All right, how did you do? This workforce product was funded by a grant awarded by the U.S. Department of Labor's Employment and Training Administration. The product was created by the grantee and does not necessarily reflect the official position of the U.S. Department of Labor. The Department of Labor makes no guarantees, warranties, or assurances of any kind, express or implied, with respect to such information, including any information on linked sites and including, but not limited to, accuracy of the information or its completeness, timeliness, usefulness, adequacy, continued availability, or ownership.